Let's talk about the base E. E is known as Euler's number. Euler was a mathematician. And E is often used when we study compound interest. So those of you going into finance as a field of study might want to learn a little bit more about Euler's number. I would suggest going to mathisfun.com and looking up Euler's number. There's lots of information there. But the base E is commonly used in both exponential and logarithmic functions. And we define E as the limit as n approaches infinity for the expression 1 plus 1 over n all to the power of 1 minus n. You don't need to memorize this definition, but what is useful to know is that it is approximately 2.7, close to 3. If you can remember it's close to 3, that's going to help you when you're asked to graph any function with a base of E. So what would be the 3 key points? And the function f of x equals e to the power of x, where e is our base. Same as any other key points. -1, 1 over a, but a is e. 0, 1, and 1e. So how do we graph using those 3 points? Well, the best we can do is use our approximation, remembering, of course, that we still have our horizontal asymptote at y equals 0. So let's put that in first. -1, 1 over e, that's approximately 1/3. 0, 1, 1e, that's approximately 3. We knew it had to be an increasing function because e is greater than 1. Every time our base is greater than 1, our function will be increasing. Let's use the transformations that we talked about in week 3 and that hopefully you've been practicing since then to graph this transformation with an exponential function. We're going to start with our basic function, e to the power of x, but you know what? Let's put that negative in front there. I think that's an easy first transformation to make. Maybe not. Start without it. Write down the 3 key points for this graph. Don't forget your asymptote. Now we'll do our first transformation, remembering that we always do any reflections or stretches or compressions. So we do have that negative. Is that going to change x or y? These were our x and y basic values. The negative is outside the function. It's changing y. And then we have that final transformation, a -3 in the exponent. Is that changing x or y? How are we changing it? Find those key points and then graph the function. This -3 was inside the function with x. That meant we were changing x. And whenever it's a -3, we know we're going to add 3 to all of our x values. Again, you should graph your asymptote first because it gives you a sense of where your graph should go. But you should know what's happening here. This negative was a reflection across the x-axis. Oh, I might want to move my x-axis up a bit. This -3 moved it 3 units to the right. So we can see that reflection across the x-axis we can see the shift 3 units to the right. Let's try another one. Okay, why don't you write down the key points for 4 to the power of x. Now we see we have 2 negative signs, 2 reflections. It doesn't matter which one we do first, so that we're all doing the same thing. Why don't we start here? Find those key points. This negative is outside the function, and so it made all of our y coordinates negative. Let's do the final transformation then. This negative sign was inside the function on x, and so we found the opposite of all of our x coordinates. Graph this function. So you see here, we have a reflection across the y-axis and the x-axis. We've changed the domain. No, we haven't. The domain remains the same, the set of all real numbers, but we've changed the range from negative infinity to 0. I hope you are graphing all of these. The best way to understand what's happening is to be doing these on paper. If you're just watching these like a movie, you're not learning what you should be learning. Here's another one for us to try. I'm going to suggest we rewrite this equation to say that it's negative 1 over 3 to the power of x plus 1. Can you see what the transformations are here then? Let's start with our basic function graph. I'm going to leave it to you now to finish filling in this table and graph this function. Now, some of you may have noticed that I didn't write down this horizontal asymptote to start, which would have caused me some problems when I'm graphing, because I wouldn't have necessarily been paying attention to the fact that this graph was shifted up 1 unit. That's important. So I hope you did the reflection first. That was a negative on y because the negative sign is outside of the function. And then we had a plus 1, which also changed y because it was outside of the function. We had a reflection across the x-axis, and then we shifted this vertically up 1 unit. Let's try graphing one more time. I'll leave this one to you. Find the final key points, graph the function. Okay, I hope you were able to do this. Our first transformation changed x. Remember, when you're adding and subtracting, we do the opposite. So we subtracted 3 from our x coordinates. And then we had our minus 2 outside of the function, which changed y. Now, this didn't reflect at all. Instead, we shifted this graph 3 units to the left and 2 units down. Remember that you should be practicing, and you have questions in your e-text as well as on Pearson.